OMG, we've literally been walking forever.
Yes.
I'm so hungry. Wait a second. Why aren't these plants hungry too?
Dude, it's photosynthesis.
Can I do that?
No, only plants can do that.
Say, how does photosynthesis work?
I'll tell you how.
Whoa! Who said that?
I did. Photosynthesis is the process in which plants and algae turn water, the stuff we drink, carbon dioxide, the stuff we breathe out, into glucose, that's like a high energy sugar, and oxygen, the stuff we breathe in. How do they do that? The sun.
But we already knew that.
Yeah, tell us something you don't know.
Alright, I'll tell you how photosynthesis really gets down. First, we're going to get the basics. Photosynthesis takes place inside the chloroplast, inside the plant cell. Inside the chloroplast are these stacks of these round little discs. They're called grana. Each disc is called a thylakoid. The stuff filling the chloroplast, but not the thylakoid, is the stroma.
So it's like the cytoplasm?
Kind of. It keeps the structure of the organelle. It also is the site of the Calvin cycle.
Calvin cycle? What's that?
Oh, we'll touch up on that later. Let's go to my explanation space.
Wow!
Dude, no way!
Gnarly.
Yeah, I know it's cool.
Dude!
Okay, that's enough. Let's get back to the Alright. Now listen up. The first step to photosynthesis is the light entering the plant. It's captured by the chlorophyll and the pigment in the chlorophyll. There are two types of chlorophyll. Chlorophyll A and chlorophyll B.
A as in apple, B as banana?
Whatever makes you happy. Let's keep on going. This A and B chlorophyll capture most light except green. That's why plants are green. I mean, most plants hate that stuff. It's like burned toast. They reflect it, so they look green because of that.
Aw, gee whiz, man. That's real interesting.
I'm glad you like it.
Like it? I love it.
Please, let me finish. We have much ground to cover.
Okay.
Step number 2. Now, it gets a little more intricate. Water is taken out of the ground by the roots, and then it is taken into the thylakoid.
Sounds good.
That's what I call a sweet treat.
Now the crazy part. Step number 3. This is absolutely necessary to photosynthesis. You know what that is? The light-dependent reaction. So, the way this works is that these tiny things called photosystems 1 and 2 that pick up the light with their pigments.
Chlorophyll?
Yes, that's when the light is picked up and it increases the energy of the electron. These high-energy, newly made electrons are passed onto the EPC.
Electron transport chain?
Yes, good. You're more educated than I thought. The electron passes through enzymes on the thylakoid membrane where it's got good old H2O molecules and hydrogen ions, where it's just one proton and oxygen. Hydrogen is now separate from the energized electron.
Hey, my electrons must be charged because I'm ready to learn.
I'm flattered. Okay, so now, there are these bad boys, the energized electrons, replace the electron's chlorophyll loss with the transport chain.
It's a big cycle.
Now, after that, we have the leftover oxygen, which is just released from the atmosphere so we can breathe it. No biggie.
The more you know.
The more you know.
The more you know. And now, these hydrogen ions are released into the thylakoid membrane.
I love it.
back to the electrons from photosystem 2. The ETC brings those electrons to photosystem 1.
Photosystem 1 and 2? How many are there?
Don't worry, there are only 2 that we've discovered. Let's continue. The pigments in photosystem 1 capture some more light to re-energize the electron. From there, NADP+, an electron carrier that is empty, picks up these electrons, and it becomes NADPH.
Whoa!
NADP+ is empty, and NADPH is full.
Wicked!
And that full carrier brings its energized electrons elsewhere in the cell for other reactions. Also, as the electrons from chlorophyll are being passed to NADP+, hydrogen ions are moved across the membrane, making it positively charged, and the outside becomes negatively charged.
Like a battery! Yes!
So it can charge my phone?
Not quite, but it does power the production of ATP. The way this works is hydrogen ions move through a protein called ATP synthase. As it combines ADP and a phosphate group, it spins around in a spin motion together to produce ATP. So all that is called the light-dependent reaction.
Wow! It makes not one, but 2 things.
Number 4, pretty simple, the Calvin cycle now.
Oh, I've been waiting for this part.
Okay, the first part of the Calvin cycle, 6 carbon dioxide react with 6 5-carbon molecules. Oh, I almost forgot. All this takes place in the stroma.
I think I remember that.
The product of this reaction is 12 3-carbon molecules, which are then converted into higher energy form. And the energy for this comes from
The light-dependent reaction.
specifically ATP and NADPH. Now 2 of these 12 3-carbon molecules are released from the cycle to be used elsewhere in the cell in the creation of sugars, lipids, and amino acids, plus a whole array of other compounds. Now, the 10 remaining 3-carbon molecules are turned back into 6 5-carbon molecules with the use of some ATP. Now these are used in the next cycle.
It makes sense now. The Calvin cycle.
Wow!
Well, now you guys know photosynthesis.
Thanks for that wonderful experience.
You really brighten our days.
I'm glad I could help you boys.
Everywhere you look, there's a heart, a hand to hold on to. Everywhere you look, there's a face of somebody who needs you. Everywhere you look, when you're lost out there and you're all alone, life is waiting to carry you home. Everywhere you look.
Science!